Alrighty, so we're going to do notes 35, which is particle and mole mass conversions. We are actually not doing this whole thing because some of these are two-step problems. So we are literally just going to do a couple of these. Actually, I think just one. Kind of want to do another one. I'm like second guessing myself if I should add another question in here. Maybe I'll represent one, okay? Because there's only one problem that's a one-step problem. Yeah, and that's all we're going to focus on. It's just one steps this week. Okay, so yesterday we did our mole mass conversions, and that was a one-step problem going from if I have this many moles, well, how much is that in grams? How much do I weigh out? And you use your molar mass, which means I add up the mass on the periodic table. I use my molar mass as my conversion factor. So today we're moving into particle mole mass conversions, but we're only going to be doing the one-step problems where we're going to be going from how many atoms are in a mole. So if I know that in 1 mole, there is 6.02 times 10 to the 23rd things in that mole. So if I say, right, this one for iron, if I have a mole of iron, well, I have 6.02 times 10 to the 23rd atoms of iron. That's how much I have them. That's what a mole means. What if I have more than that? What if I have 2 moles? What if I have 4 moles? What if I have 17.25 moles? That's the kind of work that we're going to be able to do in our next unit, is figuring out how many moles you actually need to make a reaction occur. So we need to be able to calculate how much of that is in atoms, how much of that is in grams. So yesterday we did in mass. Now we're going to go to atoms. All right, so let's do a little practice here. So our new conversion factor, yesterday it was the grams, so the molar mass over 1 mole. Today, this is the only conversion factor you are going to need, which is going to be 6.02 times 10 to the 23rd particles, because that's how many things are in a mole. And it just depends on, remember, if I say atoms, it's because it's a single element. If I say molecules, it's because it's a non-metal with a non-metal. If I say it's a formula unit that I have 6.02 times 10 to the 23rd of, it's because it's an ionic compound, which is a metal with a non-metal. So that's the only thing that's really going to be different. Is I'm going to say I have 6.02 times 10 to the 23rd atoms, or I'm going to say I have 6.02 times 10 to the 23rd molecules, or the one with formative units, okay? So I will change that word. The particle word will either be atoms, molecules, or formative units, and depends on what I'm dealing with, okay? So how many iron atoms are present in 2.5 moles? All of this unit is just the problems that I showed you yesterday, just setting them up. So no matter what we are doing, no matter what kind of problem, always start with what is given. You honestly don't even have to think about anything else except for starting with what is given. So I have 2.5 moles of iron, and to save myself some words, I'm just gonna put Fe, which is the symbol. So I have 2.5 moles of iron. And I know that I'm going to multiply by my fraction line. I'm trying to get rid of moles and get to something. So I'm trying to go from moles to atoms. Now, I just told you that this is a one-step problem. We're sticking with one-step problems this week. We'll start 2 steps next week. So if I already know it's my one-step problem, I know this is as far as it's going to be. I'm going to go ahead and put my equal sign in there. And how you know it's going to be a one-step problem, I'm going to go ahead and hint this. If moles is in the question, then it's a one-step problem. Tomorrow, just kind of go ahead and scroll down and kind of show you, not tomorrow, Monday next week, when you see that it says I'm going from sodium formula units, so that's a particle, that's a type of particle, to grams. So moles is not mentioned in the question. That's how I know it's going to be a 2-step problem, but we're not going to do that today. Today we are going to keep it at our one-steppers. So it has moles in it. I know it's going to be a 1-step problem. So I'm going to go from moles to atoms. Remember, whatever unit you are starting with is the unit that should go on the bottom, always. That is how I know what to do. So if you are routinely not writing your unit, you are not going to know what unit to put on the bottom, and you're going to flip-flop your numbers in the wrong spots. Okay, so make sure you're writing your units. The unit you start with is the one that goes on bottom. The unit that I want to get to, which is atoms, is going to go on top. So I'm trying to go from number of moles to number of atoms inside that amount of moles. Okay, Now the conversion factor that goes here, right here, it says 6.02 times 10 to the 23rd, and you have to, is it atoms, moles, or form units? Doesn't matter which one it is. In this case, it is atoms because iron is a single element. So we're dealing with atoms of iron. I just put in that number, 6.02 times 10 to the 23rd. That big O number goes there. And it's going to be over how many moles? It's just, that's how many is in one mole. Still, every time we are multiplying by these conversion factors, the number that goes with mole is 1. All right, so right now the mole value cancels. Atoms is what I am left with, and atoms is what they asked me to get to in the problem. So I know I'm ready to just put this in the calculator. Okay, so I have 2.5 times. Now here is maybe the tricky part for you. If you do not know how to do calculator stuff, let me see if I can show you. Not sure if I can. You have a little calculator. Okay, so I'm going to put in my 2.5, but I'm going to multiply by 6.02, and then I hit times 10, and see, look, I'm already messing up. I didn't put in parentheses. Okay, so I have to put in parentheses 6.02 times 10 raised. So right here, sorry, this little raise button here, this little arrow raises it up to an exponent to the 23rd, close my parentheses, and hit enter. Okay, so I'm multiplying these top two numbers, 2.5 times 6.02 times 10 to the 23rd, because they are next to each other. You always multiply the top and divide by the bottom. The bottom in this case is 1, so I don't really have to divide. So that really is the answer, 2.5 times 6.02 times 10 to the 23rd, but I did put it in parentheses in the calculator so that it did this exponent correctly. And it gives me 1.5 times 10 to the 24th. I'll have a lot of kids that will leave this off like it's not important and just put 1.5. 1.5 is very different than 1.5 times 10 to the 24th. Writing in those exponents is definitely part of the answer. Okay, so there we go. That is the answer to that question. Now I want to show you an example on our worksheet before I close out this notes. I want to show you an example on our worksheet for today, showing you the opposite form of this, when you would divide instead of multiply. So I apologize for not already having it up, but I've just decided that would be helpful for you to have. So I'm going to go ahead and find it. It's loading. So we're going to this week. Going to today, Thursday, just doing moles to atoms. What did that just happen? Weird. Click. And open up this worksheet. So we just did an example where I start with moles. So now I want to do a backwards example where I start with number of atoms. When you get your worksheet open today, it does have this little helpful chart up here reminding you the two ways to be able to write it. And so those are the only conversion factors that you will use today. Okay, so actually this first problem will work. All right, let's look at it. So I have how many moles, so now I want to know how many moles, that's my question, of magnesium. Okay, magnesium is still a single element, so it's still atoms that we are working with right now. So maybe that's not my best choice. You know, let's switch. Let's do this one down here just because it's a little harder. Okay, so let's do 6.80 times 10 to the 24th formula unit. So this is a formula unit because this is barium nitrate. Remember, barium is a metal, N and O, so nitrogen and oxygen are both non-metals. So this is an ionic compound, making it formula units instead of atoms. Okay. So we're still going, though, from formula units. That's what we're going to begin with. So I don't even think about anything else. I'm just going to write down what they give me. That's always how I start a problem, is I kind of don't even think about how I'm going to set it up first. I just write down what's given. So I have 6.80 times 10 to the 24, and I'm going to shorten it and put my funny FU in their formula units of BaNO3. Okay, now I need to set up my problem more, and I'm going to draw my line. I know it's going to be a one-step problem because we're only doing one step. So that's what I know what it's going to be. I also know because moles is given to me in the question. As long as moles is in the question, it is a one-step problem. All right, now at this point, I have started with FU units, that's formula units, and whatever I start with, you know that unit has to go on the bottom because I want it to cancel. I'm trying to get to the unit they're asking me for. So the unit I want to get rid of goes on the bottom, so it cancels. The unit that I want, which is moles, is going to go on top. Now what numbers go with this? If you scroll back up on this little handy-dandy worksheet, it's not letting me. You will see that you have two options here, but what number always goes with mole? In both of these, both options, 1 goes with mole, always. And the number that goes with particles, doesn't matter if it's formula units, doesn't matter if it's atoms, doesn't matter if it's molecules, is 6.02 times 10 to the 23rd, because that's just how many molecules are in a mole. That is the conversion factor. Let's scroll this back to the right. There we go. Okay, so now we plug in those numbers. So 1 is going to go with mole because that is what goes with mole right now. It's always a 1. The formula units and atoms and molecules gets 6.02 times 10 to the 23rd. Okay, now right now formula units cancels. Leaves me with mole, which is what my question asked me for. So I know that all I have to do is put this calculator. The only thing that's weird about this is you have two numbers now that are in scientific notation that have that weird exponent. So when you are putting these in the calculator, they will have to be in parentheses or the calculator is not going to be able to calculate it correctly, usually. Calculators are not smart. They just do what we tell them to do. All right, so when I'm putting this in the calculator, remember we multiply the top. So that would be parentheses 6.8 times 10 raised to the 24th, close my parentheses, times 1. But do I really have to multiply by 1? No, I'm going to leave that step out because I know it's the same number. And then I divide by the bottom. Well, on the bottom right now is 6.02 times 10 to the 23rd. So I'm going to hit divide, open a new parentheses setup, 6.02 times 10 raised to the 23rd, hit enter or close my parentheses, then hit enter. And my answer is 11 point. It's going to round up to 30. Yeah, I'm keeping my number of sig figs. It would actually just be 11.3. So I have 11.3 moles. So how many moles, if I have this many formula units, so I have that many little groupings of barium nitrate floating around together in a jar, if I have that many of them, I would have 11.3 moles. So way more than 6.02 times 10 to the 23rd, because I have that times 11. Okay, so I've done one of your examples on your worksheet. I've done your notes. For today, we will finish the rest of that page of notes next week.